Hey everyone, I hope you all are safe and doing good. So, in the previous lecture, we have discussed what are variables, keywords, identifiers, constant, and literals as well as expressions. A little bit about expressions, right? So, now in this video, in this lecture, we will be talking about what are data types in Java, right? So, what we will be discussing in this lecture is what are data types. Then we'll see what are primitive data types. I mean, what are two different types of data types or categories of data types. And then we'll see primitive data types and we will explore one by one all the primitive data types. Okay. Now, let's understand what is a data type. See, in the previous video, if you remember, then we have written something like this when we are talking about variables. Then we have written something like this, like I can write int a is equal to some kind of value, or int roll number is equal to suppose 100, something like this, right? So this was a variable. So in memory some location would be allocated to this A is the name of this, suppose the container, we call it like a container. The value is here 10, the name is A, and there is some address of this address is suppose maybe 1000, or addresses would be in hexadecimal form, but for simplicity purpose I am taking 1000. So this is name of that variable. Now what is this int? This is what a data type. In previous lecture also I have told you what type of value a variable can store. Data type determines this thing, right? So this variable can store an integer value. So this is what a data type. Or if I write like float marks, means marks is a variable and this type variable can store float type of data, means decimal, in which we have decimal numbers, that is float. So data type basically defines the type of data a variable can store. As well as second thing, now okay, this will store int type of data. No, so in computer's memory, how much memory would be allocated? How much space would be allocated to this A? This also would be determined by the data type only. Different data types are there, and each and every data type is having different size, or you can say number of bits required to store that type of data in memory, right? So they also help allocate memory and define operations that can be performed on the data, right? Sometime which type of operation we can perform on that particular data, that is also determined by the data type, right? Concatenation, addition, subtraction, division, or which kind of operation. So data type basically determine what? First, what type of data variable can store. Second, the size of that variable, or they determine how much space, how much memory would be allocated to that variable, right? Now, proper use of data types leads to more efficient and error-free code. So we have to use a proper use, we have to use these data types properly. I'll show you this thing also, like if you use a different kind of data type and different kind of data you store in that, then you will get an error. Like suppose int a is a int, so we can store here integer value, whole number, right? Like 10 or -5, 0, this kind of thing. But if you store here a float value 10.10, what will happen? If you store here a string value, what will happen? It will definitely give error, right? So this is what a data type is. Now we will discuss, in Java we have basically two types of data types, or let me discuss one more example, or more you can say concept first before going further on types of data types. You have heard about two concepts: dynamically typed languages and statically typed languages. Right? So I'll just give you a brief intro about these things, because you should know about these things. See, we have written something like this: int a is equal to, suppose a value, integer value we can store. If you want to store in int a is equal to float 10.10, it will give you error. If you want to store here like string, Jenny, Jenny, Jenny is a string literal in A, it will give you error, right? Obviously, within the same scope, we cannot redefine variable like int a is equal to 10. Again, I'm writing int a, so you cannot redefine this kind of redeclaration of a variable. So simply if you remove this int, and simply a is equal to 10 by 10, if you want to change the value, then also it will give error because the type is int. You cannot store a different type of data here. And this thing is known as statically typing. In Java, we have to define the type of a variable at the time of declaration only. So this is what, that's why Java is a statically typed language, because this type is static. This is fixed. We cannot change this. We have fixed this at the compile time only, right? That's why Java is statically typed language. Statically typed means the variables must be declared with a specific type. In Java, Java is a statically typed language. Okay. Now let's say like this, int x is equal to 5. Now if you reinitialize this x is equal to hello, then it will give error. At compile time only it will give error. So this type of type checking, this type would be checked for this variable at compile time only, right? So when you run this with the command java c, then only it will give you error, right? Although we run this in an IDE, so when you click the run button, then you don't know, like, I mean, it's first obviously the compilation would be done, then run would be done, running of the program would be done, execution. But this compilation and with Java we run this. So these two things we can clearly see when we run a program in command prompt, right? So this type of error you will get when you compile a program, at that time only, compilation error. So at compile time only it will check the type is int, but you are storing here string, so it will give error. It is a static type checking, right? Now what is dynamically typed language? See, in Python and as well as in JavaScript, these languages are dynamically typed language. Why I am saying this? In Python, we simply write, see, x is equal to 5. You don't need to specify here the type of the variable at the time of declaration of the variable. There is no need. So that's why, and further, suppose I am declaring x is equal to, see, x is equal to 5. Here, I have written some other code. And again, I am writing x is equal to Jenny. In Python, it's correct because the type of this variable is determined at runtime only. You don't need to specify at compile time like this would be int or this would be string. No. So this is not static. The type is dynamic. It can be changed. See, at some point of time it was storing an integer value, while later in some other point of time, at some other point of time in the same program, we are storing here string. So this is what this type of checking is known as dynamic type checking. At runtime only this would be checked. Means if you are storing here string, so at runtime only its data types would be considered as string. So these type of languages are known as dynamically typed languages, such as Python as well as JavaScript is also dynamically typed language. Right. So maybe you are thinking, I hope these two concepts are little bit clear to you. Right. I hope you are, I know you must be thinking, yeah, this one is good. You don't have to worry about the type and all, and just somewhere let's store here integer, then float, then string, and this is fine. But here you have to worry about the data type and all. Yeah, that is one advantage of this. But one drawback of this dynamically typed language is what? Suppose in a program, at some point of time, I have declared x is equal to 5. Then I have written some code. Then at some point of time, x is equal to Jenny. Then I have also written some instruction or some code. And now I want to write y is equal to x plus 1. Now this will give you error at runtime. At runtime, because the type would be checked because it is dynamically typed language. So at runtime, it will give you error like it cannot be performed, something like this. But if the same case is in Java, then when you do this thing, then only at compile time only it will not allow you, it will give you error. Suppose in IDE you are writing this program, so same IDE will give you a red line under this. As the type is int, because in Java we will write here int x is equal to 5, and you want to store a string, so this is not allowed because Java is statically typed language. So it means the errors can be detected earlier at compile time only. You don't need to wait to run a program and at runtime, because the error here in Python you will get the error at runtime. So you have to wait, right? So this is why this statically typed languages are, you can say, some advantages of over dynamically typed language in this scenario. When you want to, determine the errors early at earlier stage at compile time only, so that at runtime you will get less error. So this kind of advantage we can say of this statically typed language. Okay, you can try this out. Maybe in one program you can write in Java, in second program you can write in Python if you know something about Python, right? But this is a little bit concept about statically and dynamically typed language. I hope this is a little bit clear to you guys, right? Okay, now let's come back to the topic what we were discussing, and that is types of data types in Java. Two types are there: primitive and reference. Sorry, non-primitive. Non-primitive are basically known as reference. Okay, so let me just first discuss what are primitive data types. So primitive data types means built-in data types. So in Java we have 8 built-in data types or 8 fundamental data types, and those are references are basically, those are using some complex type of thing, complex data types such as objects and all. So these things we'll discuss later. Class is a like non-primitive data type, interface non-primitive data type. So these things we'll discuss later one by one. For now, first let's understand what are primitive data types, what are inbuilt data types, what are fundamental data types in Java. Okay, so in Java we have 8 primitive data types. And what are those? We have Boolean, and we have, broadly if we categorize this, then numbers. So again, numbers are divided into integer, then floating point number, and we have character. Yes, character also comes under numbers or numeric data type, because internally characters are stored as an unsigned integer in Java. Okay, we will discuss this thing in detail, don't worry. Now, integer again are having 4 category: byte, short, int, and long. So basically we have 8 primitive data type: Boolean first, then byte second, third, fourth, 5, and in floating point we have float and double, and one is character. So like this we have 1, 2, 3, 4, 5, 6, 7, 8 primitive data types in Java. So one by one we'll discuss all these data types, right? Now, see, first we will discuss these 4. Integer. In integer we have these 4 data types. To store an integer, integer means whole numbers. Whole number, like I want to store 10, 0, -5, 67, 1, 2, 3, 4. These are whole numbers. So these numbers comes under integer category. Now you must be thinking, why we have 4 data type to store a simple integer? Why not one? Right? So it's like in your kitchen you have different size of container. Why don't you have only one size container, one big container only to store everything, like to store those spices, like those turmeric, coriander powder, or red chili. We use those in cooking. So for those you have small container. If you want to store like some rice or lentils, there is some big container. To store atta, there is a drum or big container, like a more big container, more bigger container, right? So why different containers? Why don't your mother just buy a same size of container like this and store everything there only? Definitely to things more organized way, to just, you know, minimize the wastage of the space, right? Suppose I just want to store a, like same I have told you that there is a lip balm. This, so for this container is enough. This much container. I will not use a large container, something like this, where I used to maybe store in my kitchen rice, a large container. So definitely I'll not use that big to store lip balm. This much is enough. Okay. And if I use that container to just store my this much of lip balm, then definitely it is wastage of that, my money and as well as the space. Okay. Now, same example is same thing happens with here. Sometimes in program, we want to deal with small number only, right? And sometimes like small number means I want to store like 10 sometimes, or 5. These are small number. Sometimes you are working on a project and there you need to store like 3, 2, 5, 6, 7, this much big number. Sometime you need to store 1, 2, 3, 5, 6, 7, 8, like this much big number, right? So for storing these different sizes of integer, there are different data types. Obviously this is integer, this is also integer, this is also integer, this is also integer, whole number. But there are different types to store integers, just to optimize the memory use. And according to your requirement, according to your applications or the project you are working, according to that, you can just select which type of data you want to store, and according to that you can select the type of the data type. Okay. Now let's discuss these four data types. Now first let me just tell you the size of each data type. Like we have first we have byte. So for byte, how many bits are required? The size or the bit depth. Somewhere it is written bit depth. So the size required is 8 bits in memory, or you can say 2 byte to store a byte type of data. Size is this. Now range, the minimum and maximum value you can store. What is the range? So it's 2 raised to power minus 2 raised to power 7 to 2 raised to power 7 minus 1. So it's minus 128 to 127 basically. This much of number we can store. So I want to store simple 10 in a variable a. So rather than int, I can take it byte. That would be enough because the range is this much number we can store. Now why this range is 2 raised to power 7 and this? See, if you have only 2 bits, 0 and 1, how many combination can be there of just two numbers? At one place there is 0. At one place, suppose we have both are 0 0, both are 1 1. This one 0, this one 1, this one 1, this one 0. There are four combinations. So four number we can represent with just only 2 bits. We have only 2 bits, right? If you have 3 bits, 1, 2, 3, obviously you will store only 0 or 1. It's not like that you will have 2, 3, 4 or minus 1. Bits are 0 and 1, but positions you have like 3 bits, 1, 2, 3. You read about the permutation and combination? There you will get this kind of thing. So let me just explain this thing. If there are 3 bits, so how many arrangement you can do? Different arrangements with the 0 1. So at first place, this kind of thing you can do. If you have 3, so at first place 0 0 0. This is 1. Then 0 0 1. Then again 0. Then 1. Then 0. Like this. So there we can have basically 8 combinations. So 8 number we can represent if we have 1, 2, 3, 3 bits. Okay. Now the base is 2 because 0 1 means it's binary system. So base is 2, but here 1, 2, 3. 3 bits are there. So 2 raised to power 3. So basically how many combinations can be there? See, 8 combination. Base is 2. Number of bits are 1, 2 only. 2. So basically 4 number we can represent with this. Right? So here say base is 2 because we are obviously working in binary system. Okay. Bits are 8. So here we have not 2 raised to power 8, 2 raised to power 7. Because one bit is for sign to represent sign. Because here minus number also, positive number also. So one bit would be for to represent the sign only. When in computer you store negative number, then computer use 2's complement. 2's complement representation to store negative numbers. Right. We will not go in that much deep because this would be off track. If you want to read about this thing, how data or data representation is to be done in computer, you can search for that and you can read about one's complement, two's complement. There are three basically techniques to represent negative number: sign, magnitude, one's complement, two's complement. But the first two, signed and one's complement, have some drawbacks. There, when we store, then there is minus 0 as well as plus 0. But obviously there is no minus plus 0. 0 is 0. So this is the drawback in first two. That's why in two's complement, there is no minus or plus 0. There is 0 only. That's why two's complement representation is preferred to store negative numbers. Right? So if you want to read about this thing more, you can Google and you can search. Or maybe if I find a good link for this data representation, I can provide you that link. Right? But for now, you just remember computer use two's complement representation to store negative number, and one bit is to store the sign of that number, whether it's positive or negative. If a number is positive, the bit would be 0. If the number is negative, the bit would be 1, and that is the MSB, this bit, this side bit. And here the magnitude of the number, here the magnitude of the number. So this, if the bit is 0, it means the number is positive. If the bit is 1, the number is negative. Its most significant bit represent this. So one bit is reserved for sign. That's why we are left with only 7 bits. So that is why it is 2 raised to power 7, 2 raised to power 7, not 2 raised to power 8. I hope you got the concept. But here see, it was 2 raised to power 3 because we were having 3 bits. Here we were having 8 bits, but still 2 raised to power 7, not 2 raised to power 8, because one bit is reserved for the sign. Okay. Now this is the range of byte. Now next we have short. So for short, 16 bits are required. The range is minus 2 raised to power 15 to 2 raised to power 15 minus 1. So if you do this, then it will be 32768 to 32767. So this is for short. So like this, for int, number of the size of the int or the number of bits required to store a int variable or a int data type in memory is 32 bits. And the range is 2 raised to power minus 2 raised to power 31 to 2 raised to power 31 minus 1, and this is the number. It's 2147483648 to 2147483647. It's minus 1 because 1 is represented, 1 is 0. So that's why it's minus 1. And why 31? Because one bit is reserved for the sign, whether its number is positive or negative. Same for long. The number of bits or the size is 64 bits are required in memory, and this is the range. It's a very large number, right? Now according to your requirement, you can choose whether you want to choose byte, short, or int, or long. If a small number, you want to like do some calculation on a very small number, so go for byte. If a little bit large number, go for short. If within this range you want to choose a number, if within this range you are working on a number which is within this range, more than this, then go for int. If you are working on a very large number, you can select long. Generally, we deal with small data, so we can use byte or short. But by default, all the integer. See, whether you store any number, it's 10, minus 5, 0, or a very big number. All are by default would be considered like of type int. I mean, the by default type of all the integer is int, right? So, if you write something like this, like byte a is equal to 10. So 10 is what? It's nothing but a int literal. It's a literal fixed value, integer literal. That's it. If you write something about like short b is equal to 1534. 1534. This number is also a literal, integer literal. If you write int c is equal to a number like 321567 8, something like this. This is also a literal, int literal. Okay. More specifically, if I say this is also a int literal, int literal, and int literal integer. So means in both byte, short, and int, we store integer literal. But it's in long, it's some kind of different. Now, how this long, when you store in it's long d and I want to store some data 1, 2, 3, 4, 5, it's very big number, suppose, right? So you will specify here at the last L, whether it's small l or capital L. But we choose the recommendation is to use capital L, because if you write down here small l, sometimes it is misunderstood with one only, because one is also same and small l is also same. I will show you practically this thing, right? So here we write L. This is long literal. So basically two integer literals are there, int literal and long literal, which is having L suffix, that is long literal, and these all are int literal. So byte, short, and int store int literal, and long store a long literal. Let's do this thing practically, and I'll show you there are some mistakes also. There would be some error and how to declare all the type of variables and all. I hope this table is clear to you. Everything is written in my notes. Don't worry, and it is there in the PPT as well. So you don't need to write, right? Everything is in my notes. So let's now do some practical on this data type of integer data type. These four types. So this it was our first project in our IntelliJ idea. Right here we have some file in source. So let's create another class, new Java class, and the name I am taking is suppose integer demo. This is the name of the class. Let's just minimize this, and here let's have, we will take first, suppose we'll take a short number, that is byte. So byte and roll number. Roll number is equal to 22. Let's have a method display, or if you don't want to display in this method, you can directly call in this main also. Suppose I don't want to have any method, later we will have method, then directly does just write down main and there SOUT and just roll number. What do you think? It will give error or not? Yes, it will give error. I hope till now it's clear. Non-static field roll number cannot be referenced from a static context, because obviously this is non-static. You have to make an object of this class to access this. But if I make this static, then it will not give any error. You can directly access this roll number. So let me run this and I'll show you what. See, it will print 22, right? But definitely we will not make everything static. So what we'll do is, one thing we can do is we can make an object of this class here. How to make object of the class name, object name is suppose obj I'm taking equal to new keyword, and then this is the default constructor, right? And there we can write simply first the object, then dot operator, and then whatever this attribute you want to access, roll number. So this will also work fine. It will print 22, right? Or one more thing also we can do here, also we can have like in void display a method we can have, and this method can directly access this roll number. So we can simply print roll number as, and there just concatenation plus is acting as concatenation operator here, and roll number. So you don't need to print here. You simply call this display. See, in display, you don't need to write down any object and all, because this display is within the class only. So the methods of this class can access these members also, these attributes also directly, right? And there in main, we want to access, then in second method, then you have to like create the object obj.display. Now fine. Now let's run this and it will also show you 22. So see, the number is a short number. So for this, you can take byte. In memory, it will take only 1 byte, that is 8 bits. So it will take only 8 bits. And if you same, for the same, if I say int, suppose roll number is equal to 22. Sorry, roll number, see now, same roll number. So you cannot redeclare. See, variable roll number is already defined in this scope. Scope means within this class, wherever within this block only. This is the block, opening and closing curly braces. So within this, if you redeclare again roll number, it will give error. So you cannot redeclare with the data type. We can just like say this thing, and we can just say int roll number is equal to 22. Now for this variable, just to store 22, how many bytes, how many bits would be allocated in memory? 32 bits. So this is wastage of memory, right? 32 bits. The same task we can do within 8 bits only. Why to allocate 32 bits just to a small number, right? I hope now you got the idea why these four different types to store simple integer. Because variables are like containers only. Maybe we have one large container. Suppose we have only one large container, but now we want to store a small number, then it would be wastage of memory. And if we have a single small container and we want to deal with large integer, then it would be difficult to store large number in that small container. That's why different sizes are there, different data types are there to store simple integers, right? Okay. Now, so you have to use properly according to your need, because see, nowadays we have the memory, I mean large memory in our computer, so we no need to worry about taking the type, data type and all, because we have a large memory. But in previous days, memory was crucial. In computers were not having that much memory. So then they have, I mean, invented these different types, so that we can use, if there is some memory constraint devices, then there we can use these byte, short, these data types. Okay. But by default, for all the integer, data type is int. This also I'll show you why I'm saying this thing. Okay, now let's take this thing. If I say byte and your j rank. Your j rank is suppose 200. Let's comment out this line. See, red line, this will give error. And the red line is required type is byte, but you have provided int here. Cast expression to byte. So this casting also we'll discuss. But right now you have to focus on this thing. Required type is byte, but you are providing here int. See, this is, I told you, this is int literal, this fixed value. So let me just run this and same error. Let me just show you. See, possible lossy conversion. What is lossy conversion? That also I'll show you. But you have to focus this thing from int to byte. Okay, now here byte, but where is int? So by default, this 200 is int literal. I have told you 22, 0, 15. These are int literal. That's it. So by default, these are considered as int. Now the range is obviously out of this byte. So we cannot store this within this. So that is why it is giving you error, because the range is minus 20, 128 to 127. So for this, we can use what? Short. See, now it will not give any error. And if you want to print again for this, like here I'm printing your J rank and roll number, it will print both the things. So J rank and roll number it will print. So this is a little bit large number. You can use short also. That is also fine. But now same if I want to store here, if suppose a num1 is there of short type and I want to store 32769. See same it will give you required type is short, but you are providing here int. So same error you will get in this case also, like that lossy conversion type of thing from int to short. So this is short and this is considered as int. So by default these are considered as int literal. This is out of range from this short, so it will give you error. We can take this number as int and that's fine. Now it will not give you any error. Okay. One more thing I just want to show you here. Suppose I want to store int and phone number. So phone number is this. I don't know whose phone number is this. Don't try out. But it also gives error. Now what kind of error you will get here? Let me just run this and show you. Integer number is too large. The number is integer, but it's too large. It's out of the range of int. Range of int is, I have told you. You can check out this is out of that range. So it will give error. If I remove 1, then it will work fine. It will print this thing also. If you want to print. So let's run this and it will print roll number, J rank and this phone number. Because this is now within the range. We have removed one digit from this. Now the solution for this is, if you want to store a long number, suppose phone number, so better to make it long, right? Now it's correct. The phone number is this. But see, okay, now you are saying this is within the range of long, right? Because the range of long is huge number, definitely a huge number than this. But still, you are getting an error. Let me just show you this error. Integer number too large. Still, it gives you error integer number too large. Because this is considered as int literal, I have told you. And the compiler or Java doesn't care about that. Yeah, you have specified long and this is a long number. So don't worry, we can store it. No. It will check, yeah, this is definitely an int literal, and this is out of the range of integer. So definitely it will not check the data type. It will give error. But you have to specify that this is a long literal. This is a long literal. Just specify here. Just write down here L and that's it. And now it will not give any error. It is a long literal and your data type is long and it will work fine. This number is still an integer. If you don't put here L, this number is still an integer. So you have to write L as a suffix to tell Java that it is a long literal, it's not an integer. Either it's L or small l. But generally we don't write small l because if you write 1 and L, so sometimes it's a little bit confusing. So better to write here capital L. Now it will work fine. It can store this number and it will print your roll number as well. And let's do one more thing. If I write something like this, like number is int and suppose age is equal to 23. This is fine. 23 is within the range of int. If I write here L, see 23 is within the range of int. Okay. But you have added L here, means you have specified that this is a long literal. Now, this Java or this compiler doesn't care about that the number is just 23. It will check that, yeah, L means it is a long literal and the data type provided is int. That's why it will give you an error. Let me just hover the cursor here and I'll show you the error here only. Required type is int, but you have provided here long. So it will show you possible the lossy conversion from long to int. This is long, this is int. So if you specify any number, a long literal, you have to provide here long. Then it will work. Otherwise, if you write here int, so just without L, the number is within the range. You have to write down this thing, right? But one thing, let me just show you one more thing. If I have long and I have like a large number, and a large number is something like this. This is a large number. Okay. Now here, this number is, it will not give any error. You don't specify L here, it will not give you any error. Here, if you don't specify L, it will give you error. This is long, this is long, and this is also within the range of long. This is also within the range of long. But why you are getting error here in this case? Because this number is by default, I have told you, whatever is written here without L, if any number is written, so that would be considered as int literal. And this number is out of the range of int literal. The range is this one, minus 2, 1, 4, 7, 4, 8, 3, 6, and 4, 8. 2 plus 2, 1, 4, 7, 4, 8, 3, 6, and 4, 7. So this number is, you can check, out of this range. Out of this range. So that's why it will give you integer number is too large. But this number is within the range. So that's why it will not give any error. Although it's considered as integer, but it would be now here. Compiler will do what? It will automatically convert this into a long literal without specifying here L, because here the data type is long. So 64 would bit would be allocated, and this would be considered implicitly converted into a long, and it will be stored. So this type of conversion is called like casting, or like implicit casting. I'll I'll show you explicit and implicit casting as well with one of example. Don't worry. I hope this is clear to you. This will not give any error if you provide here L, but better to always add a suffix L if you want to specify that this number is a long literal, right? So better to add L. If you don't add L, then also it will work fine. Don't worry. You will not get any error. So here you can simply print this large number also. You can check out. So it will print this number as well. Properly, it will not, you will not get any error, right? And this large number, generally we write down something like this. When we write, then if the number is large, then we separate this with like comma, somewhere like comma, then again comma, then again comma, just to increase the readability of the number if the number is large. But in programming thing, this comma is not allowed, right? So if a number is large, suppose I have one something more, the long number, this is also the long number is too large. So this is out of the range of long. Let's remove something. If the number is too large, and if you want to make it more readable, you can just add underscore, something like this. Underscores are allowed. So you can make a number something like this. But at starting and at ending, underscore is not allowed. It's not like that you can put here underscore. No, it will give error. So, and here also at the end, if you put underscore, then also it will give error. Illegal underscore. In between, you can put underscore. But if you print, then it will print the number, the phone number without underscore. Don't worry. See, the number is without underscore. This is just to increase the readability. This thing also we can do. Right? So I hope you got byte, short, int, long. So according to your requirement, when you need to deal with a short number, when you need to deal with a long number, and this kind of thing, you can take the data type of the number. Right, now there is one more concept here. Let me just show you that thing of wrapper classes. And see, we'll just discuss a little bit about wrapper classes here, because in detail we'll discuss later. So if I write something like this, suppose for a int, I want to find min value of integer, the range. So int min value equal to, just write down here integer dot min value, semicolon. And for max value also we have this thing, max value is equal to integer dot max value. Now int, this is just a data type. Min value, we have declared a name of a variable. Any variable name you can take, a b c x y z. But I have told you the variable should be a meaningful name and descriptive. So here in this, I am storing minimum value of this int. Now integer, this is wrapper class. Wrapper class for int data type. In this wrapper class, we have like this method min value. Sorry, it's not a method, it's a constant. Public static final int min value. In min value, see the value is the minimum value of that integer. So it's a constant holding the minimum value of int, right? And this max value is a constant holding the maximum value of int within this integer wrapper class. So if you want to print, now what is a wrapper class? Let me just discuss this thing first. So see, basically what is a wrapper class? Wrapper class provides, it just provides a way to use primitive data types like int, char, boolean, byte, whatever the primitive data type, 8 primitive data types are there, as objects. We can use these primitive data types as objects, right? And each primitive data type, we have a wrapper class. For int, we have integer. For char, we have character. For float, we have float with capital letter, first capital letter. So for float, this is the class. For integer, this is the wrapper class. For character, this is the wrapper class. What is basically wrapper class and why we need it? Let's this must give you let me just give you a brief intro about this. See, if I have something, if suppose I have this clutcher, right, and I have a wrapper of a toffee or a chocolate. If I wrap this my clutcher within that wrapper, I don't have that wrapper properly, but if you have a wrapper of toffee, you can wrap this. I know within this I have a clutcher, but if someone who don't know, maybe he or she think that there is a toffee, right? So same, this clutcher is like a primitive data type, whether it's int, char, boolean or any data type. And that wrapper, we are putting some wrapper here. And that's why after putting that wrapper, it becomes an object. So as an object, we can use in this Java, not just primitive data type. Now, why we need this? Because there in later videos, we'll be discussing some like hash map, vectors, and array list. So there, these data structure stores only objects. They don't store primitive data types. So first, to store primitive data types or the values in those data structures, we convert our primitive data type as an object, then we store. So Java provides a concept of wrapping up of these primitive data types with the help of wrapper class. So we can wrap these primitive data type with the wrapper class. Like suppose this is int primitive data type and this is wrapper class for this. So outside of this, I'll put a wrapper class integer and then this will be converted. This will be act as an object, right? And like this, there are so many use of wrapper classes. This is one of them. We will discuss wrapper classes in detail in later videos. Don't worry. I hope this little bit of this need or this reason is clear to you. Why we need wrapper classes and what is a wrapper class, right? So with the help of this integer, we can convert this int data type as an object. Although it's not an object, these primitive data types will not be acted as an object in Java. These are primitive data types, built-in data types, right? So how to use wrapper classes? I'll show you and I'll discuss this thing with practical. See, so this is a wrapper class for int, and here we are getting min value and max value. There are many other you can say, but the other things also within this wrapper class we can do. But for now, just take these two things and let's just print here. Let me just comment out everything here rather than these two lines, and we will just print here. Min value of int is, the variable name is min value, and same we can print max value. So if you run this, you will get the range, I mean the minimum value and maximum value. Okay, semicolon expected. Definitely this would be an error because you have to put semicolon to end a line. So see, minimum value of int and this is maximum value of int. Now one more concept is there. I just want to tell you something interesting. This is a little bit deep, the wrapper classes and whatever concept I'm going to tell you here. We are going a little bit further here. Okay, so try to understand. If you are exhausted, you can just pause the video, take a break, and then come back. Right? But these things are important because when when you are going to sit in an interview, so everybody knows the basic details, what is an int data type and the range and all. Right? Everybody can tell this thing. But if you know a little bit deep and if you tell these things also, then definitely you will stand out from the crowd. But that's why I'm discussing this in a little bit deep. You will not get these things, you will rarely get these things in any course. Okay. Now, what is this thing? If I, right, like maximum value is maximum value. So if I do this thing, right, A is equal to whatever the max value, or A, suppose we have like int A is equal to whatever the max value here plus 1. So what do you think? See, max value is the maximum value of integer. If you are adding 1 here, means it should give error. It will give out of range, right? But I don't know. Let me just check this. It will give error or not. So whatever the value of A, let's just print that value. Let's run this and focus on what you are getting. See, A is this minus 21474,836, and see, maximum value was 2 1. We have seen this thing 47483647. Here we are adding plus 1. So it should be positive 1, or otherwise it should give error because it would be out of range. But it is printing negative value. This. Why this is printing this thing? If I do here plus 2 and if I run this, see, it again give minus, but this time it's 47 at last. So this concept is basically known as wraps around. I will tell you this concept in detail. Just wait for 1 minute. Let me just show you one more thing here. If I write something like this, suppose the second statement I'm writing int b is equal to, and whatever the value, the maximum value is 2 1 4 7 4 8 3 6 and 4 7. This is the maximum value we can store in an integer b. So suppose if I want to print this b value, so what should it will print? Definitely it will not give any error and it will print the b value. See, it is printing b value. Now what if I do here for 8? See the error. Integer number too large, right? But here it will not give you any error. It is also the same thing. You are adding this plus 1, so definitely it's same thing. But here you are getting error. Here you are not getting any error. Why this thing and why the minus value you are getting here? See, this would be checked at compile time only. The number is too large, so the compiler will give error. Now, this is like some arithmetic operation we are doing. This is an expression, right? So, some max value plus 1. So, at the time of compile time, it will not be detected like it will give what more value or less value or what. So, when this thing comes into picture, then wraps around concept is there. So, what is this wraps around concept? Let me just explain this with example here. See, if you print this thing, it will give you no error and it will print because this is the maximum number we can store in an int. If I modify this with 8, it will give error integer too large because at the compile time only it will check like, oh, this is a number which is out of range. This is integer value. It will give you error. But what if you modify something like this? If I write here 7 only, but here I do a is equal to a plus 1 or b is equal to a plus 1. And then if I print a, then what it will print? This it will print without giving any error. So this is kind of when the value exceed to the maximum limit, then overflow. This is overflow. This condition is overflow. And the binary representation wraps around. Now, what is this wraps around? I'll just I just try to discuss this with the graph or a circle type of thing visually, because then you will get it better, right? So it is just to make you understand. This is what? Int. And here we have 0, 1, 2, 3, something like this. So the positive maximum value for int is it's 2, 1, 4, 7, 4, 8, 3, 6, and 4, 7. And like this, minus 1, minus 2, minus 3, anticlockwise, minus 4, like this. So the negative number is minus 2, 1, 4, 7, 4, 8, 3, 6, and 4, 8, like this. And here we have minus 2, 1, 4, 7, 4, 8, 3, 6, 4, 7, something like this. Something like this we have. So when you try to do something like this, now this number A is this here. I want to add 1 to this A. So here overflow occurs because the binary representation of this number wraps around. Wraps around means when you go one step further, see the next number is this one. So it print this one. If you want to add here plus 2, so it will go further one more step and the next number is this one. So it will print this number. Like this, it happens, right? So that's why this wraparound concept is there. So you have to take care when you are using these things, right? These numbers. Because maybe you are thinking after this it will give error or the loop once you are using this kind of thing in loop. So maybe you are thinking when you reach to the maximum, then the loop is going to stop automatically. But this will not happen. It again go to minus like this, then again 0, then again here, again here. So this wraps around concept, this will continue, something like this. Or maybe when once you reach to 0, maybe then it will stop. So you have to use these data types precisely, right? Maybe suppose in where in counter is important somewhere, maybe in your website or some cases counter is important. And when counter reach to here, then counter again go to minus, then that is not a good thing. Okay. When you're counting something and that again go to that minus and then 0, then is definitely not a good thing. So this is kind of a wraparound concept. So this is overflow condition. There is underflow condition as well. If I store int a is equal to minus, in minus we have this is the highest or the maximum negative number. So if I do here something like this, a is equal to a minus 1. It is minus. Again I am doing minus 1. So this is minus. So this is underflow. This is underflow. And again the binary representation will wrap around. Wrap around means if it is minus 1, so we are going again minus 1, we are going this side. So this will be printed. The output would be this. If you do minus 2, one more, this would be printed. This kind of thing. I hope you got this concept, right? So maybe somewhere in interview they ask this type of tricky question also, like the value is this, I want to add this, or I want to do here a minus minus or a plus plus. These are increment and decrement operator. So what you will get? So directly, if you don't know about wraparound concept and this thing overflow underflow, you will say it will give error because this is out of range. So these small things, matters a lot in interview. If you know these things in a little bit detail, although from a fresher they expect that you know the basics, but the basics also a little bit further in deep, because about basics almost 99% students know. But if you know something extra, then you will stand out from the crowd. I hope you got this concept. Let me just show you one underflow condition as well. Okay, before that, let me just tell you something about two's complement. We'll not go in that much deep because that is not our subject. But although we are dealing with this minus number and computer's memory, so that's why I'm showing you a little bit this thing. See, I have told you in Java, this negative number are represented with two's complement, right? So how this number is to be represented and how this wrap around or this things comes into picture. See, if the number is this. Suppose the number is so in binary, this number is represented. How this number is to be represented in this form. So these are 32 bit. Int is taking 32 bits, and this is how in binary this number is to be represented. Now, if we do a is equal to a plus 1, so if we add here 1, obviously 1, otherwise all the things, these bits would be 000. So you know about binary addition. If you don't know, then you can go and check. But that's why I told you we'll not go in little bit deep because things would be added and all. So we'll not discuss that thing. Let me just show you in brief how the addition would be performed, binary addition. So it's 1 1. So 1 1 becomes 0 and carry would be forwarded, that is 1. So again 1 1 becomes 0, carry would be forwarded again 1. So 1 1 is 0. So like this. So all these ones would be zeros after adding 1 here because of the carry forward concept. 0 0 0 0 0 0 0, and when carry is forwarded here 1, so 1 plus 0 is 1. So this is the number after adding 1. Now this is what the first bit I have told you, this is the sign bit. So if this is 1, it means the number is negative, right? So this is for sure the number is negative. But how to find out the magnitude of the number? What is the number? It's not like that it is 0 0 0, so the number is 0. No. In 2's complement, how to find out the magnitude of the number? Because computer use 2's complement representation to represent a negative number. So first, apart from this sign bit, all the bits, we will find out 1's complement of this to find out the magnitude. First, find out 1's complement. How to find out 1's complement? If there is 0, change it to 1. If there is 1, change it to 0. Now, everything is 0 here. So, everything would be converted into 1. So, this is 1's complement of this number. After finding 1's complement, add again 1. So, if you add 1, then again 110, carry would be 1. 110, carry would be 1. 110, carry would be 1. So, like this, there would be all 0 0 0. All the ones become 0 0 0. And at last, again we will get 0 0 0, and after that again 1, so 1. So because 1 carries 1, 110 carries 1, so there is nothing, so 1. So this is the magnitude of the number. So if you find out this binary number, if you convert this binary number into decimal, then you will get this thing: 2147483648. So the magnitude at this magnitude is this, and the sign is negative, that we have already figured out. So negative this. That's why this number is you are getting after adding 1, this thing. I hope you do this. I hope you got this. How this wraps around concept would be done. How why this is the number, but after adding 1 you are getting this thing. How the number is converted into minus number because of this thing. Right? If you are exhausted, you're feeling exhausted, you can just take a break, pause the video, have some 5 or 10 minutes break, and then come again. Or you just first read out about 2's complement, 1's complement, binary addition, and all, then come to this thing. Right? So this is how it is going to store. But this is a little bit deep. If you're not getting, you can leave it also. Right? Now, this is like overflow condition. Now, same underflow condition. So let's just discuss this with one or two more examples. Same if I take like int b. Let's just comment out this line. Int b is equal to whatever the minimum value, whatever the min value you have get, minus 1. So you will not get any error, and you can just, if you print this b, you will get a positive value. This thing I have discussed. See why you are getting this thing, because of the wraparound concept. But directly you cannot store. But directly, if you want to store here, like suppose int c, and here I want to store minus 49, then it will give error. Directly at compile time only it will figure out that okay, this is out of range, integer is too large. So it will give error. Here directly we cannot store. But yeah, this thing we can do. Minus this, minus 8, minus 1. This thing we can do. See, numeric overflow in expression. So this is fine. You can just print here rather than B, let's print C. So we're not printing B, so let's comment out this line. We are printing only A and C. A and C. Let's run this and I'll show you. See, you are getting here positive value. It's not B, it's C. C value we are printing. C value is this. So directly we are not storing the number out of range. We are doing some arithmetic operator. We are applying some calculation. This is the expression. That's why it is not giving any error. Directly if you provide an integer out of range, it will give error. Right? The compiler will give error. But here compiler is not able to understand like it would be a large number or not. That's why you are not getting any error here. Okay, now few more things I want to tell you. Other than this int literal or long literal you assign to this integer or long, we can initialize this with some other literal as well. So what are those literal? These are decimal. Suppose I write here int a is equal to 37. So these are decimal, 10, 5 or any number decimal we are representing, right? But we can assign here an octal number as well, or a hexadecimal number, or a binary number directly. If you want to assign an octal number here, generally we don't assign hexa or octal or binary number. We directly write decimal value we take. Addition of two numbers or anything, we directly take the decimal numbers, right? Those literal. We don't take this thing, but you have some idea. If you have some idea, then it would be better. We can assign this in other way also. Octal number, octal means base 8. So octal number will start with a 0 always, and after this it will have a number from the set 0 to 7 because the base is 8. So from 0 to 7 digit we can use. So suppose I write here 3 7, this is correct. 0 is correct. 0 1 2 5 is correct. But if you write 0 8 1, this is not correct because 8 we cannot use. From 0 to 7 we can use. So this is invalid octal number. Hexa is what? Hexa number will always start from 0x. This is more into number system. If you want to skip, you can skip this. Either 0x or 0 capital X. You can start with this. So hexadecimal number, in hexadecimal number we can take from 0 to 15. So from 0 to 9 all the numbers, and 10, rather than 10 we write A, 11, B, 12, 13, 14, 15 like this. So C, D, E and F. Till F we use. 0 to 9 numbers and then A to F we use in hexadecimal number system. In decimal we use from 0 to 9 any number. That we use in real life also. Right, from 0 to 9. But in hexadecimal, 0 to 9 number and then A to F. So like this, 0x and I write like AF. That's correct. 0x 1 2, that's correct. Only 0x and suppose we have 0f, that is also correct, right? Binary number will contain only 0 and 1, so always be preceded with 0 B or 0 capital B. And here I write like 1 0 1 0 1 0 1 1 or 0 B 0 1 0 1 1 2. Oh sorry, not 2, we cannot write 2 here. Obviously in binary base is 2, so you can just use 0 or 1 or 0 1, something like this. So these are binary number, these are hexadecimal, these are octal. So I can write here, if you write 0 7, then this is an octal number. Then octal number, when you get this, the output, then you will not get 37. This octal number would be converted into decimal. Then that output will be given to you. Now, if you want to convert this 37, if it's an octal, then what is the formula? I'll tell you. Here we write like, we have 37. So 7 into base is 8, 8 ki power 0 plus 3 into 8 power 1. So it would be 24 plus 7. So whatever value you will get here, that would be, I think that would be 31. So let's show, I'll just show you practically this is correct or not. Same for hexadecimal, if you want to print like 0x12. So the decimal number equivalent to this is 0x means it's hexadecimal. So 1 2. Convert this into decimal. So have to convert. The base is 0 for hexa, 0 raised to power 1, sorry, into 2 plus 16 raised to power 1 into 1. So you can just 16 plus 2. It will give, I guess, 18. For binary, have to convert this binary to decimal. This would be same like binary is 1010. So 0 into 2 raised to power 0 plus this 1 into 2 raised to power 1 plus this 0 into 2 raised to power 2 plus this 1 into 2 raised to power 3. So 8, this is 0, this would be plus 2, this would be plus 0. So it would be 10. So it will print 10 like this. So rather than integer literal, you can assign this int data type with octal number, hexadecimal number, or binary number as well. Although we don't use these numbers, we don't assign these numbers when we write our programs or when we are writing, working on projects. We use decimal numbers only, right? But just for the sake of information, you have the knowledge. This is also possible. Let me just show you practically this thing. So let's just comment out everything here and let's take more numbers. Here I am taking suppose a number that is int and suppose oct number is equal to 037, right? And let's just print in display. Let's just comment out all these things. And in display I'm printing just this octal number or the value of this OCT oct number is plus and whatever the variable name. That's it. This I'm printing, and in main we just created the object and we are calling this obj display. In display we have only one line. Let's run this and it will print, I guess, 31. See, the number is 31 in decimal. So this was octal number, right? Now if I take one hexa number is equal to, either you can write here 0 x or you can write here 0 capital X. Both are fine. So if you write like 1 2 semicolon, and in the next line let's print our hexadecimal number. Let's run this and see. It will print both like octal number and hexadecimal number. So octal was 31 and hexa number is 18. So this number is equivalent to 18 in decimal. Same with binary also, we can print like int binary number is equal to, that would be preceded with, sorry, it's 0, either small b or capital B, and suppose 1010. So same, let's print this. So three number we are printing, first octal, then hexa, and then binary number. So octal was 31, hexa is 18, and binary number is 10. So you can initialize int data type with decimal, hexa, and binary number as well, rather than simple integer literal. But we generally don't use these things when we are writing programs. This is just for the sake of information. You can do this thing also, right? But one more thing I just want to show you. Let's just delete all these things and I want to show you one more thing, right? In this program only. So if I take, this is for your assignment. If I take like byte and we take like, let's find out minimum value of byte using the byte wrapper class dot min value. Same, let's find out max value. See, this byte wrapper class is java.lang package, and this is already imported by default, automatically imported here. So byte dot max value I want, and you simply print these two value. So we are simply printing using the integer, sorry, the wrapper class of byte. We have found the min value and max value of bytes. So let's just print first this, and then I'll show you something interesting about this thing. So we know this minimum minus 128, maximum 127. Okay, this is not something new. Let's do some experiment. And I am doing like byte. Now a is equal to whatever the min value minus 1, or whatever the max value. Let's do for max value plus 1. What do you think? In int, it was working fine. It was having the, I have told you, the wrap around concept. It was wrapping around. But here, see, you are getting an error. Provided type is int and required type is byte. Let's run this and I'll show you the error. See, possible lossy conversion from int to byte. From int to byte. Now, okay, byte is fine, but it's not int, right? We are finding out just minimum value in byte and we are adding plus 1. So it should give like minus 128 after wrapping around. So with byte and short, the thing is when we perform arithmetic operations on byte, short, or char we will see later. So on byte and short, then these operands, see this is operator plus and the value 1 and max value, these are considered as operands. Suppose I write something like this 2 plus 3. So here plus is operator and 2 and 3 are operands on which we are performing the operation. So here this max value and 1, these are operand. So when we are performing arithmetic operation, plus, minus, or any arithmetic operation with the byte and short, these data types, then the operands are automatically promoted to int, automatically converted to int. This is implicit conversion, and this compiler will do automatically, regardless of their original type, whether it's byte or short. And the operation would be performed. And after performing the operation, the definitely the result would be int, right? So if the result is int, then by default, this Java does not automatically downcast the result back to byte or short, because maybe doing so could lead to loss of data or truncation of data. That's why you are getting an error here, because this is converted into int, this is also int, the result is also int, and if the result is int, we cannot store that into a byte. So to store this, you have to typecast this, right? Let me show you this thing. How to typecast. So this is the thing, you are getting an error. But maybe you are thinking here it should do some bytecast, like so typecast, or you can say here it should give some wrap around, not casting. Byte from 0, 1, 2 like this. Here would be minus 128, minus 127, 127, 126, something like this, right? Minus 1, minus 2. So this is minimum value is what? Minus 128. If you do minus 1 again, then it should give you 127, but it is giving you error. Why so? Because these operands are converted into int. Int. On int, it is performing some operation, right? And the result is also an int. Now, result is int here, but here we have byte. That is not possible. Java will not downcast this because int is large in size and byte is small in size. So maybe it it will think that it would lose some data. So by default, it will not truncate it. So the solution is you can truncate it. That is why it is not like, suppose we have two classes, or suppose we have something like this. See, upcasting promotion has been done by Java automatically. This was in byte, right? So automatically it was converted into int, the operand. This is promotion. Suppose, let's take one example. Suppose on my table I have, there are some walnuts. I have just put these walnuts to dry up. And my mother asked me to put all these walnuts in a container. So she gave me a container, but that container is small. When I put all those walnut in that container, there are few walnuts still left. So I can do what? I can take one more container, or I can take a big container and then just put all the walnut in that container. That's it. If you have those walnut in a large container and your mother asks to put those walnut in a second container, and which is small, right? Then the container which is having right now walnut. So it's not like that you will put the walnut in the small container and whatever the left you can just discard those walnut and you just throw these walnuts into dustbin. No, definitely without asking to your mother, you cannot do this thing, right? Although you can ask like, these walnuts are left because this container is small. So what to do with these? Can I discard? Can I throw this in dustbin? If your mother say yes, then you can throw. So like this, you cannot downcast. You cannot throw something. You can take a big container without asking your mother. That is fine. So same here. Small number would be converted into a higher number. Byte is small, int is higher without asking automatically because there would be no loss of data, right? And because of high precision, so that the addition or whatever operation you are performing, that would be done with more precision. That is why this byte would be converted into, these operand would be converted into int. But Java will not downcast these into byte without asking us because of the fear that it may lose some data, right? But here we know that we can do this thing. If the solution of this problem is, you can do casting, type casting. Now, what is this casting? Conversion of one data type to another data type. That is simply casting. So, two type of casting. Implicit, I have told you, from smaller to larger data, that is implicit, automatically would be done. Explicit, we do from large to small data type. So the result is int. So if you want to convert this into byte, because a is of byte type, then you have to write something like this. Byte a is equal to, here in bracket, the name of that data type. You want to typecast this, and then min value minus 1. This will not give you any error. And now this will wrap around. It will give you the value 127. So this is casting. And why we need casting, that also I have shown you, right? So this thing basically happens with byte and short and char. In int, this thing will not happen. In int, it will automatically wrap around. Int will not be converted automatically by into long, because int literal is different, long literal is different. Two integer literals are there. One is int, I have told you, one is int, one is long literal, which is having l as suffix. And as this byte, short, and char also, but that thing we'll discuss later. Byte, short, these are containing whatever there at right hand side, that is a simple int literal. So that's why they are promoted into integer here in this case. Right, let me show you this thing with example. So to typecast this, we just write here byte and in bracket just put this in bracket. And that's it. It will not give you any error. And now you can simply print this value. It will, if you print this a, it will perform wraparound and it will give you minus 128. See, the value is minus 128. This is min value, this is max value, and this is the value a we have printed, a. This is minus 128. So with byte and short, you have to do it explicitly, the typecasting. Same with short. So you have to try this out. This is your assignment. Same with short. Using short wrapper class, find out min value, max value, Then add max value plus 1, min value minus 1, and try to print here the variables and do and see what you are getting, right? But in int and long, automatically this will work and no error you will get. Integer, about int I have told you. About long, let me just show you. For long, we have wrapper class this long dot, suppose min value. Same, let's find out max value. Let's just comment out these byte. And for long, let's just print here. Rather than this here only, I will print something like this, that min long value minus 1. And in second one, let's just print max long value plus 1. See, it will not give you any error. It will automatically wrap around. And I don't know, so you are getting a huge value. Min long value minus 1, so you are getting plus. Max long value plus 1, you are getting minus, right? So like this is a huge number. So automatically it will wrap around, right? So now we have discussed, you will get everything in my notes as well as in PPT. In PPT, it's not in like detailed form. In notes, you will get. But you have to do this thing practical with me only, whatever I'm writing here. You have to try this out. You can pause the video and try this out, right? And if you're getting any error, you can just let me know. Once we'll have a live class or in discussion also or in WhatsApp also, you can post. So this thing we have already discussed, the data types, their range and everything, right? And so this is the practice problem for you. Declare a byte variable to store day of a month. Then the solution is this. You can see the explanation and the solution. But before seeing the solution, you have to declare a variable. Same, declare a variable of type short to store current year. And for int, declare a int variable to store population of a large city. Right. Practice problem for long is use a long to represent the number of stars in a Milky Way, or any practice exercise you can take. Wrapper class is also we have discussed, and wraparound concept is also there that we have discussed only, right? So this, see, the wraparound can lead to unexpected results if not handled properly, and that thing I have shown you. Unexpected results you are getting because of this wraparound concept. So you have to handle this properly. And if you know what is this concept, then you are able to handle this, right? Casting also I have shown you how casting is done, what is typecasting. Converting a value from one data type to another, implicit as well as explicit casting. Implicit means automatic conversion to a larger data type, from int to long, from byte to int, from short to int. Explicit means manual conversion from uh, potentially some losing of data can be possible. For example, long to int to byte, int to short, right? This we do. Explicit means we do. Implicit means automatic. So this is some casting example also. You can see I have shown you that example as well, right? So this is a small number is equal to 10. Then long big number is equal to, I'm assigning this small number to this big number. So this will automatically do conversion. The small number value is 10. So compiler will automatically convert this into long and store this here. But it's not the case. This is a long variable, long number having this value. Now we are taking again int. A variable name is back to small. You cannot directly assign another big number. This will give error. But you can typecast this into int and then you can assign. This is explicit casting, right? So this is all about integer data type, byte, short, int, and long. We have discussed many things about this. So it's time to practice this thing, right? Now, in the next lecture, we will see other primitive data type, that is float, double, boolean, and char, right? So that's it for this video. Now we'll see in the next video. Till then, bye. Take care.